Welcome back. We are starting a unit on systems of numeration. I find this to be one of the exciting units. I took a class in college as a math major where I learned about the history of math, and that's where I actually first saw a lot of these concepts. And I thought it was so much fun, and I'm really hoping that you guys have some fun too. We're not going to go nearly into the same depth I did because I took an entire semester-long course on stuff like this, but we're going to give you a nice little taste of some of the number systems, ancient number systems, what people did before mathematics got to the point where it is today. Okay. So we're first going to be looking at additive, multiplicative, and ciphered systems. And then later, not in another video, we'll look at place value systems, which is what you're more familiar with nowadays with our current Hindu Arabic numerals. But we're going to go way back and look at additive, multiplicative, and ciphered. But before we do, let's cover a few definitions, just little nitpicky kind of definitions. You probably use the word number frequently when you're talking about stuff mathematical. A number is a quantity. You're like, oh yeah, I know that. You know, if I say 2, I mean there's 2 items. You know, that's how many items I have. But that is different from a numeral. I don't like. There's a distinct difference. I know sometimes we use them interchangeably, but there really is a distinct difference. The numeral is the symbol you use to represent that quantity. So when you write down a 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, what you wrote down is the numeral representing how many there are. So that's the language to communicate the quantity or the number. And then a system of numeration has a set of numerals, so a language to use to express these quantities, along with rules or schemes, so that when you write down a 2 and a 3 together, you know the rule means that's 23, the scheme, with our system. And all these systems had their own schemes or rules, so we're going to go over how they worked, basically. All right, so the first kind we're going to look at are called additive systems. The name is exactly what it sounds like. In an additive system, you add. And that's it's a broad or general term. Some of the additive systems, you also do some subtraction, but hey, it's kind of a broad way of describing these. But you're going to take your numerals and find some kind of sum, even if it's a sum with negatives. All right, and the first example that we're going to look at of an additive system goes all the way back to 3000 BC to the Egyptians, when they used hieroglyphics. I'm sure most of you have heard the term hieroglyphics and picture writing, and that's exactly what it was. And in a minute, you're going to see the pictures they used for representing certain quantities. And this was one of the first additive systems, dating to around 3000 BC. So that was quite a while ago. That was, over 5,000 years ago. They had symbols for various powers of 10. How convenient. 10 fingers, 10 toes. Why not talk about quantities with powers of 10? And then they did have some rules or some procedures they used for multiplying and dividing, even way back then. We will actually talk about duplication and mediation later in this unit, not today, but they used duplication and mediation to help them with multiplication and division. Now, they did not have 0. In fact, 0 was one of those concepts and numerals that took a little while to come about from what we can tell from records. But surprisingly, they did understand fractions, which I find kind of interesting. Like, they don't talk about 0, but they talk about parts of things. I mean, it makes sense they have to talk about parts of things. Like if you're buying or bartering or whatever, you might only want half of what somebody has in their basket. But to me, you would still somehow have the concept of 0. So I don't know. We also are limited as far as our knowledge of what we can find in caves or archaeological digs or wherever. So sometimes our knowledge is a little spotty, but as far as we can tell, they didn't have 0. Okay, so what did they have? They had symbols like these. For the number 1, they used a picture of a staff like a walking stick kind of staff. It's basically a vertical stroke that they would draw. And I think that's fascinating because all the way down, even 5,000 years later, still to represent 1, we basically draw a staff. It's basically what we do. And that's like holding up 1 finger. So that's kind of interesting. Then remember this, they did powers of 10. So for 10, they used a heel bone, or an arch shape. And then for 100, they did a picture of a coiled rope or a scroll. Like back then, there's scrolls of paper that rolled up on the end that had that, coiled rope kind of shape. For 1,000, they used a picture of a lotus flower. For 10,000, they used a picture of a little crooked finger that they drew. For 100,000, a fish. And then for them, 1,000,000 was this ginormous number, so they would draw this amazed person, like, oh my gosh, that's so big, amazing. And that was their symbols. So if they wanted to express a number, they would use some combination of these symbols, and the values would add up to come out to the total for that number. Okay, so let me show you. Let me give you an example of one of their numbers, and I'll show you how it writes out, what it comes out to. And then we'll take one of our numbers in Hindu Arabic and put it into theirs. Okay, so the first one I'm going to show you, this one consists of 4 fingers. So I'm going to do my best to draw the little crooked fingers. And they didn't have place value, but usually you'll find in your book and in my math lab that these things are kind of written larger to smaller, much like our place value works. But again, they don't have place values, so you don't have to write them all in the same line. You could write them out of order, and that would be okay. It's just not very organized. All right, they had a lotus. This number has a lotus flower, has 2 of those scrolls, and then a heel bone or an arch. Okay, so let me change color here. Let's go with the light blue. So if I look at these, I have 4 of these fingers, and those were 10,000 each. So that comes out to 40,000. Then for the lotus flower, let's see, I like changing colors. I'm going to change colors. For the lotus flower, there's 1 of those. And remember, the lotus flower is 1,000. So there's only 1 of those at 1,000. So that's 1,000. And then we have the 2 coils at 100 each. So that's 200. And then we have the 1, I haven't used orange yet. We have the 1 arch or heel bone at 10. So that's 10. So you would take those and add them up. It's an additive system. And you would end up with 41,210 in our values today. And that's it. That's all you have to do to convert one of their numbers, the Egyptian hieroglyphics, to our system, to Hindu Arabic. Just take the values of each one, add them up, see what you get. Okay, let's go the other direction. Let's say we have 242 in our numbers. We have a 200 that we need to represent. We have a 40 that we need to represent. And we have a 2 that we need to represent. Okay, so for the 200, I know that a scroll is 100. So I can do 2 scrolls for that. That's the 200. And then for the 40, a heel bone is 10, so I can do 4 heel bones. And then for the 2, I know a staff is 1, so I can just do 1, 2. 2 staffs. And now I have it in Egyptian hieroglyphics. That's what the number looks like in Egyptian hieroglyphics. So 2 scrolls, 4 heel bones, and 2 staffs. These are fun. I have fun drawing them. Okay, that's another example of an additive system. Well, I have Roman numerals listed next. Now, Roman numerals use addition and subtraction and the multiplication principle, but they are still technically an additive system, even though they have the little extras in there. Roman numerals were used in most European countries until about the 18th century, which is really hard to imagine. They're kind of clunky when it comes to doing mathematics with them, which might be why some of those European countries were not the forerunners of mathematical discovery. They use selected letters of the Roman alphabet, which we'll see on the next slide. And then, like I said a minute ago, it uses addition and subtraction and the multiplication principle. The advantage over the Egyptian hieroglyphics is they needed fewer symbols for writing large numbers because of that availability of subtraction and multiplication in there. And nowadays, you'll see the symbols still being used on clocks because they're easier to read on clocks. And then you can, if you think for a minute, you can probably think of something else, at least in the US, where you see Roman numerals at least once a year. And then worldwide, you see Roman numerals every 2 years. I'll give you about 15 seconds to think where you might see that. Okay, at the risk of sounding like Dora the Explorer, if you said the Super Bowl for the US, you are correct. And if you said the Olympics for worldwide, you are correct. So we still see Roman numerals for specific things. Not entirely sure why the Super Bowl uses them. If you know why, hey, send me a message and tell me. And I'll add it someday to my videos, but I don't know. It's cool looking. And it's kind of fun little mental exercise to look at it and try to figure out, well, what number is that? Where are we? Okay, moving on. Roman numerals. Here we go. They use an I for the number 1, a V for the number 5, an X for the number 10, an L for the number 50, a C for the number 100, a D for 500, and an M for 1000. You might be looking at that and going, well, I know that the hieroglyphics only went so high, and then they had that astonished person, because to them that was just huge. But this doesn't even seem to go as high as the hieroglyphics. What the heck? Well, they had ways of going higher than these letters. They would put a bar over a symbol or a group of symbols if they wanted to multiply that value by 1,000. And that's how they could go above and beyond their M. A couple of other guidelines that you're going to have to follow as we do this. This is additive as you start from the left and go right. If you go from larger to smaller, you add them up. If you go smaller to larger, you're going to subtract. Only powers of 10 can be subtracted, and they can only be subtracted from the next 2 higher numbers on the chart. So you can't subtract like 1,001. You can only subtract 1,000 with 500 and 100. So it's always, the subtraction always has to be within two values on the chart there. Symbols can't be repeated more than 3 consecutive times, I should say. So it always bugged me because when I was growing up, my parents had a clock that had Roman numerals, and for some reason, for the number 4, it had I. Had 4 I's in a row, and I'm like, that's not correct. It's not supposed to be more than 3 consecutive. Once you get to 4, instead of doing 4 I's, you start using that subtraction rule. So you put like I in front of V, so you can subtract 5 and 1, which I'll show you in a minute. So that always bugged me, but oh well. And that's pretty much it. That's the rules. I'm going to show you a couple of examples to help you see how these rules work. But there you go. Okay, so the first example, I'm going to write a Roman numeral, and then we're going to convert it to Hindu Arabic. All right, MCM LXIV. Okay, as I'm looking at this, you know, I'm going to spread them out because I feel like I need more space to really talk about what's happening here. All right, I see my M, which is 1,000. A C is 100, and M is 1,000 again, and L is 50, and X is 10, and I is 1, and a V is 5. But notice that they don't go entirely larger to smaller. If they go larger to smaller, then you add. But as soon as something goes smaller to larger, you're going to subtract those somethings. Okay, so in this case, the M being 1,000 is fine. We'll stick with that. But notice that for C and M, C comes before M. C is smaller than M. C is 100, M is 1,000. And since the smaller one comes before the larger one, we have to subtract. And say that that's 900. So we have 1,000, then we have a 900. Then for the next ones, we have an L, an X, an I. So those are going down, 50, 10, 1. But then we have a V, which is 5. So suddenly we went up. So as soon as we go from a smaller to a larger, we know that those two have to be subtracted. So the 50 and the 10 can be added. And that'll give us 60. But the 5 and the 1 have to be subtracted, which is going to give us 4. And then we add all those up, and we get 1,964. Or 1964. So it's additive as long as you're going larger to smaller, but as soon as you have a smaller and a larger together like that, that subtracts, but then you'll still add up all your results. And then notice too, like C and M are fine because on the chart you have C, D, M. C and M are within 2 of each other, 2 hops. I and V are within 2 of each other, 2 hops. So you can subtract those. You couldn't put IL. Those would be too far apart. There's a different way to express 49. You wouldn't put I in front of L. You would do it a different way. That's the basic rules. Now I did mention about doing larger numbers, like with 1,000. So let me take a Hindu Arabic number here and put it into Roman numerals so that you can see how the thousands work. Okay, so for this one we have a 6,000 that we need to figure out. All right, normally 6 could be written as 5 plus 1. So 6 is VI. But then we can put the little bar over it to say 6,000. Okay, then for 200, we can just do 2 C's, 100 plus 100. Then for 70, so we did 100 plus 100 for 200. For 70, we can do 50 plus 10 plus 10. So L is 50, X is 10, X is 10. And then for 4, remember my clock earlier, I can't put 4 I's together because that would be too many symbols straight across. You can do 3 together consecutively, but you can't do more than that. So I'm going to have to resort to subtracting. So I'm going to have to do the whole 5 minus 1 kind of situation. So put an IV like that for the 4. And there you go. So there's that Hindu Arabic converted to Roman numerals. All right. Moving next. This lesson also gets into multiplicative systems. They feel pretty... If you can do the additive systems and if you can do Roman numerals, the multiplicative systems aren't going to feel drastically different. Like, in fact, the traditional Chinese system we're about to do feels kind of like Roman numerals in that you are going to do some multiplying and then adding again. Okay, here's some of the characters. Since your tests are in my math lab right now, at least during this pandemic and all that, you don't have to worry about trying to draw these symbols. And please bear with me as I do this. I'm going to do my very best to draw these. I may not be perfect, but we'll see what happens. But there you go. There's the chart with the numerals, how they match up with the Hindu Arabic numerals. And here are some tips. Instead of writing left to right, we're going to write top to bottom. If a smaller number appears over a larger number, then you're going to multiply those quantities. We often use this for the powers of 10. If you'll see some kind of numeral from 1 to 9, like you've seen 8, and let's say it's followed by a 100. That means you do 8 times 100 and you get 800. So it'll be some numeral from 1 to 9 followed by a power of 10, 10, 100, 1,000, 10,000. It means you're going to multiply. If it's not followed by that, then you're going to be able to just add the result. And then for zeros, they're kind of have their little rules there too. If you have something with consecutive zeros in the middle of your numeral, only 1 0 has to be written. It's not necessary to write more than 1. And if there's zeros at the end of a numeral, you don't have to write them. And I'll make sure to do examples of both. Okay, so let me do my best here to write one, and then I'll break down what we're doing. Professor Li Zhou would probably look at this and go, "What did you just write?" Because, Chinese is his first language, it is not mine. So, I'm just going to do my best. Okay. So, hopefully it looks close enough on the chart for you to see that the top numeral is a 6, the next numeral is a 10, and the numeral after that is a 2. Now, since 6 is small and appears above a 10, we're going to multiply 6 times 10 and get 60. Then 2 just appears at the bottom, so 2 is just 2. You add those up, you get 62. That's it. So if you see is like a 1 through 9 appear above a power of 10, you know to multiply, and then once you get all your results, add them up. Okay, this next one, again, bear with me. I'm going to do my best here. Alright, it's going to look like that. This is actually supposed to be an 8. And then the next one is going to be a 1,000. Then it's supposed to look kind of like that. The next one looks like this. That's supposed to be a 5. The next one looks like this. That's supposed to be a 100. Next one again looks like this, so it's another 5. And then the last one looks like this. So it is a 10. All right. So we have an 8 above a 1,000. So that's 8 times 1,000, which gives us 8,000. We have a 5 above a 100. So 5 times 100 is 500. A 5 above a 10 is 50. And nothing else. So we add them up. We get 8,550. Now notice that This ends in a 0 right there. But notice that the Chinese numerals does not have a 0 at the bottom. Not necessary. If your numeral ends in a 0, you do not have to put the 0 on the bottom. It kind of, as you work it out, it just makes sense that there's a 0 there. Okay, let me do one more of the Chinese numerals. Let's say we have 4003, and we need to write those. So we need to deal with the 4000, and we need to deal with the 3. 4000 is 4 times 1000. So we're going to put a 4 over a 1000. We do not need the 2 zeros in the middle, both of them. We're just going to put one of them. We're going to put a 0 in there just to show that there's zeros. We do not need both of them. We don't need 2 of them. And if it was like 4,000,003, we would only need 1 0 still in the middle. You would do 4, 1,000,000, 0, 3. Like, just an example. So we're going to do this. So we're going to do a 4 first. Looks kind of like a little house or something with a little window. We're going to do a 1000. Then we'll do the 0. It's actually like a face. If you look really closely, it looks like an older man with a mustache. I'm sure I am drawing this incorrectly as far as like order, and etc. Students over there do a whole bunch of lessons on their calligraphy, and it takes them like a lifetime to master it. And then you have your 3. All right, so sorry, apologize to anybody who is proficient in Chinese. I know I butchered that, but you get the idea. So we did a 4 and a 1000 for 4000. We did a 0 in there just to show that there's zeros in the middle, and then we put a 3 at the bottom. And there you go. There's your Chinese. All right, one more system for this video. We are going to go to ciphered systems. In ciphered systems, there are numerals for numbers up to and including the base and some of its multiples. To see what numbers represented, add up the values of the numerals. This one's actually, to me, one of the easier ones, but there is, again, potential for a lot of symbols to be used, like in hieroglyphics, but not quite as much as hieroglyphics, because you don't need, like if you're doing 4000, you don't need 4 1000s. They actually have a different way. There's different ways you can deal with things. The Ionic Greek system developed around 3000 BC, so comparable in time period to your hieroglyphics, has these symbols seen on the next slide. They weren't the only ciphered system. They had Hebrew, there was Hebrew, Coptic, Hindu, Brahmin, Syrian, Egyptian, Hieratic, and early Arabic systems that were also ciphered. But this one's a big old chart. Notice how, like, for the hundreds, you have a symbol for 100, a symbol for 200. You know, like in the hieroglyphics, for 200, you would have had to do 2 100s. Whereas here, you could just do a sigma for 200. So it's a little more condensed than the hieroglyphics, but still kind of clunky, especially if you're trying to do advanced mathematics right now with it. So, but there's your chart. If you're reading a Greek text and you saw numbers like this, and you saw a little mark that looks like an apostrophe to the right and above a numeral, that helped distinguish it from a letter. So then you knew it was sigma in that case. If it had the little apostrophe, you knew it was a number versus sigma, the letter. We're not going to worry about that so much because we're not reading Greek text with mixtures of numbers and letters. But we do need to worry about the little iota. It's like a tiny I. If you see that to the left and above a numeral, it means to multiply the value by 1000. It's kind of like the bar over the number when we were doing Roman numerals. Multiply by 1000. That's pretty much it for the rules. Okay, so let's see a couple of examples. Let me do one let me write down one in their symbols, and we'll convert it, and then we'll go the other direction next. All right, so we have an omega. And if you have your chart handy, you can kind of, as you're doing it, you can look and find them on the chart. We have an omicron, which looks like an O. And then for this example, we have an eta. All right, so all we got to do is we got to look at each symbol and see what its value is. Our omega is 800. Our omicron is 70. And our eta is 8. So you just figure out what each of the values are. You add them up. You get 878. And that's it. Not bad, huh? Now what if I gave you one that had the little iota? What would you do with that? Let's see here. Let me do one next to here. So I lied. I'm actually going to do 3 examples. All right, so this one, I put a beta with the little iota, just a little I up there in the upper left. So you probably see that on the chart. You see beta is actually 2, but remember the little iota means you multiply 2 times 1,000. And then omega is 800. Then we have a pi. You're like, oh, pi, 3.14159, blah, blah, blah. In this system, it's not 3.14. Pi is 80 in this system. Just rely on your chart. All will be clear. And then we have a gamma. Looks kind of like a Y. And that is 3. So we end up with 2,883. That's how the thousands work in there. Okay, so let's do one where we convert it to their system, like 2008. Well, we don't have a 2000 in our chart, but we can do a 2, which is beta. And we could put the little iota there. Woohoo, that's 2000. We do not have to put zeros in there. So unlike Chinese system where you put like a little 0 symbol in there, we do not have to do that for this. All we do is go straight now to the 8 and we put a little eta in there. Looks kind of like an N. And that's it. Voila, we are done. All right. I like these, so I want to do one more. I don't want to stop there. Let's see here. Let's pick a good one. Or, I don't know. They're all good. But, so let's say you want to do 543. Okay. You need a 500, a 40, and a 3. So 500 is phi. So if you're going to do that, you just do a little phi. And then if you're going to do 40, you got to do mu. Looks like a little u. And then if you're going to do 3, you do the little gamma. And there you go. That's it. All right. Thank you for joining me with additive and multiplicative systems. To me, these are fun. They're the most fun of everything we're going to be doing in this unit. But we can't stick around here forever. In the next lesson, we're going to look at place value or positional value numeration systems. And this will start to look more familiar because eventually we're going to relate this to the base 10 number system that we use today, which is a place value system. So we will look at that in the next video, and then pretty much wrap up this unit with some fun computational methods like that duplication and mediation that I talked about earlier. All right, so I look forward to seeing you.